the Internet of Things urban farming project. Our aim is to help urban dwellers to make the most use of limited space by using aquaponics that is controlled by the Internet of Things. So when we decided to move the IoT makerspace from the school into the wider Mbari community, we were met with a subtle chorus that went something like, "You're bringing us the internet, but what we really want here is food." And because we're so passionate about bringing the internet to this local community, we took a few steps back and decided to creatively sneak in the idea of the internet in the form of food that this community required. We found an IoT-driven aquaponics system a suitable bait.
Aquaponics is not our own invention. It has been in existence for years, and building aquaponics systems has been made easy by the internet, specifically YouTube. However, the internet and YouTube are not easily available to most folks in communities we work with, like Mbari.
So we decided to learn aquaponics on the internet in order to impart our knowledge to the Mbari community so that the systems are developed by the community for the community. Our ultimate goal was to teach the Mbari community how to set up their own aquaponics units in a cooperative way, deriving the benefits of economies of scale together as a community.
The majority of YouTube aquaponics videos are for large-scale farming where vast areas of land are available. We, however, decided to experiment with aquaponics with a household twist for high-density communities like in Mbari.
Our makerspace is very young. Our makerspace creed is the Moore's Law. The creed keeps us focused, and we are able to build innovative projects using small devices, but powerful devices. We use the Arduino microcontrollers. We also use the Raspberry Pi single board computers to build powerful, useful projects for the community.
We love the opportunities availed by open source hardware and software in developing cyber physical systems. Open source allows us to share our code with others and to learn from the best.
Most IoT systems utilize the cloud to save data, which is very expensive in our country. Cloudlets offer an alternative to cloud computing as it processes data on the edge of the network, something commonly known as edge computing.
The simplicity of connecting IoT devices with LoRa network makes IoT fun. We can also create our own wide area network using LoRa network and chip devices.
This is our system. We use the Arduino Uno microcontroller. It is connected to the electroconductivity, the temperature, the pH sensors, and then the water level.
We have developed this Node-RED application that receives data sent by sensors from the Arduino microcontroller that shows the owner of the system, the prevailing state of the whole system in real time. So here's our Node-RED application. And then this is our Arduino, and these are the nodes of the sensors that are connected to the Arduino. This is the pH sensor, and our pH should be ranging from 6.7 to 8.6. And this is the temperature. This is the temperature sensor node, and our temperature should be ranging from 24 degrees to 36 degrees. If the temperature is below 24 degrees or above 36 degrees, an email is sent to munyaradzi@gmail.com to alert him about the increase or decrease in temperature. And this node represents the electroconductivity sensor. Our electroconductivity should be between 35 to 87. And then this is the fish tank sensor. This one is to measure whether the fish tank is leaking or not. So if the fish tank is leaking, it will show that the fish tank is leaking using this node. Our application has been open sourced so that other communities can replicate and reproduce the project within their own communities. You can download the code on our GitHub repo.
We also created a mini data center for the community in the form of a Raspberry Pi cluster that manages Docker containers using Kubernetes.
Here we have pegged together plants of strawberries, rape and spinach, totaling 560 plants per unit to maximize on small yards in high density areas like Mbare.
We also made our structure mobile and very easy to assemble and disassemble, thanks to the design and insights from the University of Zimbabwe employees that include Dewa from Mechanical Engineering and Tonderai from Civil Engineering Department, who volunteered their time to help us.
For sustainability's sake, our system runs off the grid, so as to utilize the abundant sunlight available in Zimbabwe. As you can see, it's on a very bright day. The system also has a built-in security system that can actually protect the fish.
Now that we've confirmed the technical feasibility of this IoT-inspired aquaponics project, the next step would be to get into the community and scale the project, drawing inspiration from the interesting concept of foodscaping. Only that this time, we are using the internet and our mini data center as the brains behind the farming.